So here is the first problem we'll be going over today. This is about charge distributions. Okay, and if you don't already know the problem, you can pause the video and read it. But a quick summary of it is that we have a bunch of charges, 25 in fact, and it starts at 0.5 meters, and every meter is another charge up until 24.5 meters. So we're trying to find out the electric field caused by all these charges on a test point that is at 50 meters. So the distance between our last charge and the test point is 50 meters, so that's really important to note. And the first thing we need to understand is that how do we find the electric field, the magnitude of the electric field from one point to the test point? And the way we find that is by using the equation that let me go ahead and use a better pen. That E is equal to K times the charge Q over R squared. And the thing about this problem is that since we have multiple charges and only one test point, we're going to have to find the E for every point and add all those E's together and see what the result is, and that would be the electric field at the point at 50 meters. Okay, so if we were just looking at the point at 24.5 meters, so if we were just looking at this point, the electric field would be equal to K times 1 coulomb over 25.5 meters squared. However, since there are all these charges, we're going to have to use a summation. So we're trying to find the sum of all the electric fields of all the charges. And since we know our first charge, or the one closest to the test point, is at 25.5 meters, what we can do is that we can increase the value of R by 1 meter each time to get to the next charge and to the next charge. And we're going to be doing that a total of 24 times. So we start with I is equal to 1 or to 0, and this goes 24 times, and it's going to be K times Q all over 25.5 plus R all squared. So for example, if I was equal to 2, we will be testing the point at 23.5, and we will find the electric field magnitude at that point. And if we crunch the numbers and plug this into a calculator, we get that this is equal to 1.08 times 10 to the 8th newtons per coulomb. Okay, and that is it for this video. In the next one, we will be talking about this problem.